Today I'm going to talk about simplifying square roots in its simplest radical form. So let's first look at the question on the board. As you can see, this one is simple. It's the square root of 16. Because 16 is a perfect square, we can simplify it easily because we can say that 16 equals 4 times 4, square root that. We can also say that 4 times 4 can be written as square root of 4 square, and because the square and the square root cancel each other out, the square root of 16 equals 4. Very simple. Final answer. Let's look at this problem. Square root of 28. Now, 28 is not a perfect square. So to simplify it into its simplest radical form, we have to look at our factors of 28 that are perfect squares. If you recall what perfect squares are, perfect squares would be 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared is 36, 7 squared is 49, and so on and so forth. So, looking back our square root of 28, what are our factors of 28 that are perfect squares? We can say that, well, 4 is a factor of 28 and 4 is a perfect square. So we can say that 4 times 7 is 28. Now we can further split our radical into two separate radicals. So if we say the square root of 4 times 7, we can also say that the square root of 4, I'll write it as the square root of 4 times the square root of 7. Now 4 is a perfect square, so it's 2 times 2, 2 squared, square root of 2 squared is 2, and you're left with the square root of 7. And that's how we solve that in simplest radical form. Let's look at this problem, square root of 135. So let's find the factors of 135 that are perfect squares. So let's do 135 divided by 4, which is our first perfect square. That doesn't give us a whole number. Let's try 135 divided by 9, which is 3 squared. That gives us 15. So we can say that this equals square root of 9 times 15. Now we're going to look at 15 here. Are there any other factors of 15 that are perfect squares? No. So we can continue on. So let's go ahead and split up our square root. So we can say that it's square root of 9 times square root of 15. Square root of 9 is 3. And that leaves us with the square root of 15. And that is our final answer. Let's look at this problem that includes variables. In this case, we have a y square. That's a perfect square, and we're going to square root it. As we said before, the square and the square root cancel each other out. Therefore, you can say that square root of y squared is y. Now, if you remember your laws of exponents, we can also say that the square root of y squared can be written as parentheses y squared to the power of half. If you recall, we can multiply our exponents across if it's separated by the parentheses. So we can say that y squared times half gives you y. Okay. Now, simply put, when you have a square root, you can pretty much halve your exponents. So half of 2 is 1. Similarly, we can say y to the power of 4 equals y squared. So you have y squared. Now, if you have, say, y to the power of 28, half of 28 is 14. So the square root of y to the power of 28 is y to the power of 14, and so on and so forth. Now, what if you have an exponent which is not an even number? So what we want to do is when we're solving it, we want to take out our even exponent. So a cubed is the same as a times a squared. Then if you wish, you can split it two separate radicals, which is square root of a times the square root of a squared. Now, the square root of a squared is, as we said before, the square and the square root cancel each other out, so you're left with a, and you still have that square root of a, and that would be your final answer. To wrap up this lesson, let's try something a little bit more challenging. So here we have the square root of 128 x to the 6 y z to the 5. So when you're first trying these problems, I recommend splitting them up. So we're going to do the radical of 128 times the radical of x to the 6 y, radical of y times radical of z to the 5th. Let's now deal with each radical separately so we don't confuse ourselves. Let's think of our factors of 128 that are perfect squares. So let's put in 128. Let's do 128 divided by 4. We get 32. Let's try to find a bigger perfect square that's a factor of 128. So 128 divided by 9. No. 128 divided by 16. Yes, that looks good. Let's do factor of. So we found that 128 is 16 times 8. Then let's look at our x to the power of 6. As we covered before, this is an even exponent and you have the square root, so we can divide our 6 by 2 to get x cubed. Now our y is not a perfect square, so I'm just going to leave it as the root of y. And like in the previous example, I'm going to split my z to the power of 5 to a perfect square, which is z times z to the 4th. Now let's simplify. Square root of 16 is 4, and we're left with the square root of 8 times x cubed times square root of y times, now I'm going to square root my z to the power of 4. So that leaves me with, I'm going to halve the 4, so that leaves me with z squared times what was left with, which was our square root of z. Now let's focus on our square root of 8. Our square root of 8 can be simplified further because 2 times 4 is 8. I'm going to break this down further. We have 4 square root of times 4 times our x cubed times our root y times our root z times our z squared. Now if you notice, I repositioned my square root of y and square root of z a little bit. Let's simplify this further. So I am left with 4. Now the square root of 4 here, I'm going to split it to square root of 2 times square root of 4 times square root of my y times my square root of z times my x cubed times my z squared. Now I'm going to simplify this again. So I'm going to bring down my 4. Square root of 4 here is 2. And I'm left with that root 2 times this chunk, which I'm going to copy and paste as so. I'm going to do my final simplification. 4 times 2 gives me 8. And I'm going to put my x cubed and z squared in front of my radical as well. So I'm going to put x cubed times z squared. And we can finally finish up with our terms in the radical, which is 2yz. And that's how we solve that. If you like my video, please be sure to like and subscribe. If you'd like to see any other topics, please leave a comment below. I have notes and lessons for sale, and I also offer tutoring sessions. Links down below. I hope this session was helpful, and thank you for joining me.